Buddy, we're looking at 1.1, first video of the year, solving simple equations, and we're going to be doing that with inverse operations. Hopefully we all know what inverse operations are, and we know how to use them, so this section will be pretty simple. Inverse operations, just as a refresher, are kind of like saying opposite operations. The opposite of addition is subtraction. The opposite of multiplication is division. So inverse operations are the things that undo its pairing. So how do we use them? That's exactly how we use them. We use them to undo operations being done with its pair. So if there's some addition that's happening, I'm going to use subtraction to undo them. We use the inverse operation to undo it. If there's multiplication happening, I'm going to use division to undo that. So let's take a look at some examples and see how that type of thing works. Part A, example 1. We have x minus 7 equals negative 6. Alrighty, so the idea in this equation, like you would know from pre-algebra, is to figure out what that x value is, and we do that by isolating the x variable, by getting it by itself. So the question is, what do we have to do to get the x by itself? And what we have to do here is the inverse operation of the surrounding items. So I have minus 7 here, so my inverse operation is going to be plus 7. And when I do something to one side of the equation, I have to do it to the other side. An equation is a lot like a sort of balance in a way. I have two different sides of the balance, and I need to make sure that if I add one blue scribble to this side, that I also add one blue scribble to this side in order to keep those things balanced out. So when I add 7 over here to get the x by itself, because negative 7 and positive 7 equals 0, I also have to add 7 to the right side to keep things balanced. Negative 6 and positive 7 comes out to 1. X plus 0 equals 1. X equals 1. Alright, so our first equation was quite simple, nice and easy to solve. Now let's look at B. B is a little bit more difficult, really not because of the complexity of the equation, because really there's one step again, but it's more complex just because there's decimals. So don't get too freaked out. What I'm actually going to do here is move the decimal place over 1 to the right for all of the numbers. Every number in here now has the decimal place moved over to the right 1. And then once we're done with all of our calculation, I'll move the decimal place back over. It's just a little trick to help get through and not be so freaked out by that. So I'm going to do the inverse operation here. I'm going to subtract what is now 34. And what that gives me is 34 minus 34 equals 0, so that's no longer there. 5 minus 34 is negative 29, so y equals negative 29. And I could double check that. I could plug the 29 back into the equation and make sure that it's correct, and that's definitely a good practice to do. But what I actually need to do is move that decimal place back over, because my answer really isn't a negative 29. My original equation didn't have a 34, and my original equation didn't have a 5. I need to move the decimal place back over to make that 2.9, because my original equation had 3.4 and 0.5. Alrighty, so 2.9, negative 2.9 is what y equals. Now part C brings up a new sort of issue, which is this guy right here, pi. A lot of times students will get scared when they see this symbol and start thinking, okay, I have two different variables going on here now. I have an h and I have a pi. But in reality, that's not true. Pi isn't a variable. Pi just represents another number. I could easily say this equation is something like h plus 2 times 4 equals 3 times 4. And that would be another representation of exactly what's happening here. This is 2 times this number equals 3 times this number. Now pi isn't a number we don't know, it's simply just a neater way of writing 3.14159. continuing. So we're going to do the same operations that we would do with some of this other stuff. I have addition of 2 pi, so I'm going to subtract 2 pi. Got to keep my equation balanced, so I'm going to subtract 2 pi from this side as well. And what that leaves me with is that h equals 3 minus 2, which is 1 pi. So that equation was actually quite simple as long as we can get over the initial fear of seeing pi in the equation. Now, D and E. D and E move on to, I guess what you could call slightly more complicated, because multiplication and division are a little bit more complicated than addition and subtraction. But D and E deal with doing the inverse operations, either multiplying or dividing. So we're going to do the exact same thing that we did in the first three. We're just using different operations now. I want to get the x by itself. Right now, the x is being multiplied by the number pi. So if I want to do the inverse operation, I'm going to have to divide by pi. Dividing by pi. So over here, I have pi times x divided by pi. The whole reason I did the inverse operation was so that those things would go away and I would get the x by itself. Now, if that worked over here and I had a pi on the top and a pi on the bottom, that's going to be the same deal over here. I have a pi on the top and a pi on the bottom. Those things will cancel out. X equals 3. Now, why does this work? It's a lot like 3 times 2 over 3, something like that. I can cancel out the 3's and say that my answer is 2. 3 on the top, 3 on the bottom. Right? And we can check this, and we know that this is true because 3 times 2 is actually 6. 6 divided by 3 equals 2. Alrighty. Now, last one, the trickiest of all. Because we're doing multiplication, because we have a negative number, and because it's a fraction. Do we remember how to do the inverse operation with a fraction? Hopefully, this isn't new at all, and we're just doing a little refresher here. I am multiplying by negative 3/4, which means I'm going to divide by negative 3/4. And I did it on the left side, so that means that I have to do it on the right side. Dividing by, that is a 5. Why would I draw a 5? Negative 3/4. Alrighty. So the left side, fantastic. These things are going to cancel. That was the whole reason I did the inverse operation. And it equals negative 2 divided by negative 3/4. How do I divide by a fraction? I really hope some of you are watching this thinking, I need to multiply by the reciprocal, because that is the solution. Negative 2 over 1, that's simply the numerator, negative 2, in fraction form, and I'm going to multiply it by the reciprocal of the fraction, negative 4 over 3. Alrighty, dividing by a fraction is the same thing as multiplying by the reciprocal. I'm going to say that so many times this year you're going to be sick of it, but you will remember it. So now all I have to do is multiply. Negative 2 times negative 4, 8. 3 and 1, 3. N equals 8 over 3. Fantastic. Alrighty. Almost to the end, we have a multiple choice question here, which brings up an interesting point here. And I'm not going to necessarily show you how to solve this because there's multiple steps going on, but we want to identify which value of k makes this equation true. And I'm going to let you solve this one on your own. In however way you feel more comfortable. I'm sure that a lot of you will do the same way, which is kind of like the cheap way out, but it's the way that you can figure out right now. And then we'll look at multi-step equations at another point. So for now, this is on your own, and I will check in on this next class that I see you. What I really want to look at here is the example 3 real-life application, the word problem, because this is going to be the type of problem that you're going to see a lot, and you have to be able to take the words and build them into an equation. Alrighty, so let's focus on how we do that. The melting point of a solid is the temperature at which the solid becomes liquid. The melting point of bromine is 1/30th the melting point of nitrogen. Write and solve an equation to find the melting point of nitrogen. Okay, so let's just take what's important. Melting point of bromine is 1/30th the melting point of nitrogen. That's the words that I took from here that I can now try and create an equation for. The melting point of bromine is 1/30th of the melting point of nitrogen. Okay, well, can I fill anything in? What do these things mean in terms of numbers? Now, you might not have seen this over here, but I am given a little more information. The melting point of bromine is -7 degrees. Alrighty, now as I move down this equation, melting point of bromine is. The word is an indication for equals. Right? If something is something else, something is equal to something else. 1/30th, that can stay because that's just a number, of the melting point of nitrogen. 1/30th melting point of nitrogen. So this number equals 1/30th of something else. Of is an indication of multiplication, if we didn't realize that. The product of this and this. Of indicates multiplication. The melting point of nitrogen, that's what we're trying to find out. I'm going to make that a big N variable. So my equation looks like -7 equals 1/30th times N. Okie dokie, I'm going to rewrite that just a little bit clearer. And now I can figure out how is it that I'm going to solve. Because I have one step, I know I have to do the inverse operation, which means I have to divide, because this is multiplication in here, but I'm dividing by a fraction again. So hopefully we learned a little bit from the reverse side of this page that I have to divide by 1/30th or multiply by the reciprocal. The reciprocal of 1/30th is 30. Multiplying by 30. Over on the right side, fantastically, these things will cancel each other out. On the left side, I'm going to be just multiplying a 7 and a 3. 7 times 3 is 21, but it's not a 3, it's a 30, so I'm going to add a 0. It was a negative times a positive, so my resultant is negative. That equals N. Very good. -210 degrees is the melting point of nitrogen. Alrighty, do the assigned problems. I will see you in class next time. Good luck. I hope the first video is a success for you because we have a lot more to go. I'll see you guys later.